everyone from Institute of Aeronautical Engineering. Myself, Dr.M Purushotham Reddy, Associate Professor and Head of the Department of Computer Science and Engineering. Now, I am going to discuss about minimum spanning trees. To find this one by using Kruskal's algorithm. So, this Kruskal's algorithm is an alternate algorithm for Prim's algorithm. Here, the core objectives of this design and analysis of algorithms are mathematical approach for analysis of algorithms, methods and techniques for analyzing the correctness and resource requirements of algorithms, different paradigms of algorithm designs, including recursive algorithms, different concurrent algorithms, dynamic programming, greedy algorithms, backtracking, branch and bound, and graph algorithms. Strategies for solving problems not solvable in polynomial time. Now, the course outcome for this chapter is, after successful completion of this course, students will be able to apply greedy algorithms for finding solutions of minimization and maximization problems. So, at the end of this course, using this greedy algorithm, the students will easily solve problems and also find minimization and maximization of that problem. Next, Kruskal's algorithm. This Kruskal algorithm used for finding minimum spanning tree. The algorithm is E, cost, n, t. E is edges, cost is the cost of that edge, n is number of vertices, t is that tree, which the t is the set of edges which consists of minimum cost spanning tree. Now, construct a heap out of the edge cost using EP5. So, we form the EP5. For I equal to 1 to n, do parent of I equal to minus 1. So, initial starting vertex is taken as parent vertex, that will start with 1, that one value is minus 1. Minus 1 will start from that one. That is the meaning of that one. I equal to 0, and also initially will take minimum cost value is 0. While I less than n minus 1 and heap not empty, then do repeating, delete a minimum cost edge u, u from the heap. So already in that heap already we added to all the edges. So we choose one minimum cost edge from that one and we delete from that heap and re-heapify using adjust, and again re-heapify using the adjust. Now j equal to find of u, j value is taken as find of u, and k equal to find of v. So next we find the nearest vertices. And also if j not equal to k, then I equal to I plus 1. We're repeating this one for remaining vertices. T of I comma 1 equal to u, T of I comma 2 equal to v, and we can find the edge cost value, that is minimum or not, we check it. So suppose that one is minimum cost, so minimum cost equal to minimum cost plus, we add that cost value. Now union of j comma k. Now we add to that one to minimum cost spanning tree t. If I not equal to n minus 1, then write no min spanning tree. So if I not equal to n minus 1 means all n minus 1 edges not repeated in the spanning tree. That means all n edges not appears in the spanning tree. So there is no spanning tree. So otherwise, return the spanning tree with minimum cost value. If I not equal to n minus 1, so then we return no spanning tree. Otherwise, we return the minimum cost value of the spanning tree. So here in this Kruskal algorithm, first sort edges in the graph in increasing order. Select the shortest edge. In Kruskal algorithm, you select the minimum cost edge value. Loop exit if all the edges examined. Select the next shortest edge. Mark this edge as examined and end the loop. This guarantees an MST, but as it is built, edges do not have to be connected. Now this is the example problem on this Kruskal's minimum spanning tree. In this finding minimum spanning tree using Kruskal's algorithm. So this is the given graph. Now here first of all in this graph we find the minimum cost edge first. So in this graph here we see that the cost values are 4, 5, 2, 7, 8, 14, 9, 3, 15, 12, 21, 6, 8, 10, 20, 13, 24, 17, 11, 9, 19. So among these minimum cost values, 2. We choose that one first. So first we sort all the values. The values are 2 first. Next here 3. Next one is 4, 5. So all this way. In the increasing order we sort all that values. So that values are 2, 4, 5, 6, 7, 8. 2 9s is there 9, 9, 10, 11, 12, 13, 14, 15, 17, 18, 19, 20, 21, 24. These are the edge cost values we sort in the increasing order. First we choose minimum cost value, that is 2. Choose that one. So we choose this one. So next minimum cost value 3. We choose this one. Next minimum cost value is 4. We choose that one. Next minimum cost value is 5. We choose that one. Next minimum cost value is 6. 6 we choose. Next minimum cost value is 7. We choose. Next minimum cost value is 8. Suppose we choose this 8. It forms a loop, so we won't choose this one. Next we choose minimum cost value is 9. Here this 9 is there. Here this 9 is there. And also another 9 here is there. So we choose any one. Suppose we choose this one. And also next minimum cost value is 9 again. So we choose another 9. So that's why here we choose R method also. We choose either that 9 or this 9. Next we choose next minimum cost value. Next minimum cost value is 10. We choose that one. It won't form any loop. Next minimum cost value is 11. We choose that one. Next minimum cost value is 12. But it forms a loop. And also here we observe that it covers, here we choose any edge now, it forms a loop. Because this in this path here we observe that it covers all the vertices of the graph. So we stop here and we find the minimum cost value of the spanning tree. This minimum cost of the spanning tree is 3 plus 9, 12, 12 plus 5, 17, 17 plus 4, 21, plus 2, 23 plus 7, 30, plus 6, 36, plus 10, 46, plus 9, 55, plus 11, 66. The minimum cost of the spanning tree is 66. So, in Prim's algorithm also, we get that minimum cost value is 66. So, once again, here we see that, once again, once again I am repeating to finding the minimum spanning tree using Kruskal's algorithm. Now here, first here in this is the given graph. For this graph, we find minimum spanning tree using Kruskal's algorithm. First we sort all these edge cost values in increasing order. So that is shown here in next slide. Here we see that we sort that one. First we choose minimum cost value, that is 2. Next minimum cost value is 3, we choose that one. Next minimum cost value is 4, we choose that one. Next minimum cost value is 5, we choose that one. Next minimum cost value is 6, we choose that one. Next minimum cost value is 7, we choose that one. Next minimum cost value is 8. Suppose we choose 8, it forms a loop, so we won't choose that one. Next minimum cost value is 9, so here we have 2 9s, we choose any one of this one. Suppose we choose this one, we choose. And also next we choose next 9. So that's why here we choose next 9. Next minimum cost value is 10, we choose that one. Next minimum cost value is 11, we choose that one. Now here we observe that this path, it covers all the edges, ones or not? Yes, it covers all the edges, all the vertices. So this path, it covers all the vertices. It covers all the vertices means now it is a spanning tree. Suppose now we are going to try to connect any other edges to this given path, that edges forms a loop. So that is whenever any edge forms a loop means that is not a spanning tree. So we won't connect that type of edges. So now this is a minimum spanning tree. So what is the minimum cost of the spanning tree is 66. In Prim's algorithm also for this the same problem, we find the minimum spanning tree with minimum cost value is 66. That minimum cost value is same, but connecting the edges, that will be different. Next, what are the differences between Prim's and Kruskal's algorithm? Prim's algorithm, here we see that the tree that we are making or growing always remains connected. Whereas in Kruskal's algorithm, the tree that we are making or growing usually remains disconnected. So in Prim's algorithm grows a solution from a random vertex by adding the next cheapest vertex to the existing value or existing tree. Whereas in Kruskal's algorithm grows a solution from the cheapest edge by adding the next cheapest edge to the existing tree. Prim's algorithm is faster for dense graphs. Kruskal's algorithm is faster for sparse graphs. Once again, listen. Prim's algorithm, in Prim's algorithm, here the tree that we are making growing always remains connected. Whereas in Kruskal's algorithm, the tree that we are making or growing usually remains disconnected. In Prim's algorithm, it grows a solution from random vertex by adding the next cheapest vertex to the existing tree. In Kruskal's algorithm, first you sort all the edges in increasing order. First you choose the cheapest edge, next you choose next cheapest edge, and you connect to the existing tree. This Prim's algorithm is faster for dense graphs, whereas this Kruskal's algorithm is faster for sparse graphs. So thanks to everyone. So up to this, that minimum cost spanning tree using Prim's algorithm, Kruskal's algorithm completed. Thanks to everyone.
Like, share and subscribe. Hit the bell icon for more updates.